Here I have an example of a problem that we did not do in class. I just wanted to show you guys a radical function that was transformed a little different from the previous one. Actually, we're going to put a negative out there as well. So we have f of x equals negative radical x plus 6. Notice the plus 6 is inside my radical sign, and plus 2 on the outside. So my parent function is just going to be radical x. And again, the reason for that is because this 6 and this 2 and this negative, that's all extra stuff that transforms it. So the original is just the x and the function type, which is the radical. So here's radical x as my parent function. Now the transformation, if you remember from your notes, a negative always flips it. So I know this flips. I also know that since this 6 is inside the parentheses, it's a positive, which means it's going to move left 6. Because on the inside it's always the opposite of what you think. And since that 2 is on the outside and it's a positive, it's going to move up 2. So if I wanted to draw a sketch of this, if you remember, the parent function of a radical looks like this. And now we have to move left 6 here and up 2, so it'll be somewhere in this spot. But we also flipped it. So instead of going up like this, my graph is going to flip and go down like that. And if we wanted to compare this to our calculator, just to get an idea, you can see that this is my parent function, and this here should be the transformation which looks like what we drew over here. So that's good. Now, again, if I want to compare the domain and the range, I can first think about what the domain of the parent function is and what the range of the parent function is. So if I look at my parent function here, domain is left to right. If I start on the left, I need to look at where my graph starts, which is at 0 here. And it's going to go forever to the right, so it's going to go to infinity. And the range is bottom to top, so I start at the bottom here. So it starts at 0, and then it just keeps going up to infinity. So again, that's my parent function. So now if I look at my f of x function here to figure out the domain and the range, I have to start on the left and the right again. Well, I know that I moved left 6, so that means my domain also went to the left 6, so now I actually start at negative 6. And if you look at your graph here, you can see right here at negative 6 is where your graph starts to exist. There's nothing out here past negative 6. So I'm starting here at negative 6, and again I also know that because I moved left 6. And I'm going this direction. Sure, my graph is going down, but again, that has to do with the y-axis, which has to do with the range. I care more about the fact that it's moving to the left very slowly, or sorry, to the right very slowly, so I'm going to positive infinity. Now my range is a little different here, and the reason it's different, it's not going to go to positive infinity, is because of this negative that flipped it. So instead of heading to positive infinity, I'm now heading to negative infinity. So I start at negative infinity. And if you look at your sketch, here, you'll see that this range is going down, so I'm going down to negative infinity. Now the top of this, you'll see, I moved up 2, so my range tops out at 2. So that's my domain and range for f of x. And now if I want to compare increasing and decreasing, you'll see that your parent function is increasing, but your f of x here does not increase at all. It's actually going down, which means it's decreasing. So it doesn't increase, but it does decrease. Now when I look at decreasing, I have to look at the x-axis. Since I moved left 6, I know that my decreasing must start at negative 6, and it's going to keep decreasing forever this way on the x to positive infinity. You also see that the domain and the decreasing are the same.